In this video, I want to share with you a way of visualizing geometrically the content of a first order differential equation. And we're going to do this through something called a slope field. So let's get into it. So slope field. So recall that a first order differential equation is something of the form y prime equals f of xy. We've been talking about various cases for f of xy in the last set of videos. We talked about what happens when f of xy is a function of x only, in which case this becomes a very standard kind of calculus problem where you just have to integrate to find the general solution. We talked also about what happens when f of xy is a function of y only, in which case this is what's called an autonomous equation. And then we can use this reciprocal trick that I talked about in the last video to solve such equations. We're also going to learn at some point soon about separable equations. That's good for future videos. And we're going to learn how to another way of approaching the problem of autonomous equations, and more than that. Okay, but right now I'm not interested in that so much as I am in it, again, providing a geometric understanding of the content of this equation. Okay, here's what we want to do. Let's set up an xy plane for ourselves. So the familiar xy plane, there it is. And we know that at each point x comma y in the plane, we can put that x comma y into this function, right? And we get out some number when we plug in that x comma y. Now, what this equation is asserting is that y prime is going to be equal to that f of xy. And we know that the derivative, the y prime, sort of encodes for us something about slope. So what we're going to do is we're going to draw at each point x comma y, we're going to draw a little line segment of slope f of xy. And I'm just going to imagine that we do this at every point in this plane here. And I can't literally draw for every point in the plane, so I'll just draw a few of them. Okay, and you can imagine they, do all sorts of interesting things like this, and maybe they start curving out this way a little bit more, and I can't really draw all of them, right? But you can imagine something like this happening, all sorts of interesting dynamic behavior. It kind of feels like maybe like an electrical field or maybe the movement of water. I remember when I was a child, I used to literally play in the gutters. I would stick leaves in the gutters as water was flowing down them, and I would see how they would float downstream and that sort of thing in my residential suburban neighborhood. That was a favorite pastime of mine. Don't judge, okay? Okay, so that might be an example of a slope field. It's very complicated. I can't draw literally everything here, but you get the picture. This is the basic way in which we are going to construct a geometric visualization of this differential equation. Now, inside this, how do we see solutions to this differential equation? Here's how. So you could imagine starting at a point in this plane, and I'm trying to draw that with a little green point here, and following this slope field so that at every point along this curve, the little line segments in the slope field are tangent to that curve. Let me say it again. We're going to draw a curve in green, starting from this point right here that I've already drawn, so that the slope field is tangent at every point along that curve. So if I do that here, we go along here, and I'm trying to draw it so that the red line segments are tangent to this curve, something like that. Yeah? You could imagine such a thing. And if I start at a different point, like if I was to start like here-ish, let's say, right? There. Then I would get a different curve. I might get a curve that looks like this. Again, the goal is to try to make this curve so that it is everywhere tangent to the curve, to the slope field here. Whatever, okay? And I could do more, maybe something like this would also be such. And over here, maybe it looks something that, okay? These green curves are called integral curves. The green curve, I'll just say the curves are called integral curves. This is just jargon. Okay. The slope field is tangent to these curves at every point. All right. And so and what these integral curves are, they are pictures of the solutions to this differential equation. Okay, so when you have integral curves, because the red line segments are tangent to these green curves, you're going to have these curves satisfying this differential equation here. Because after all, y prime, as you know from your calculus days, represents the slope of the tangent line to the curve, right? So if we take, in particular, like a fixed point, just imagine a fixed point x comma y right there. Oh shoot, what just happened? If we take a fixed point x comma y right there, right? And we imagine the tangent line to that curve. Well, that tangent line is going to have slope given by y prime. But y prime is precisely f of xy, and that's going to be the f of xy is going to be precisely the slope of the slope field that we find in the slope field. Okay, cool. If we, now again, this is a very crude picture because, you know, I'm a human being here. But we can look at an example from the textbook, which is much more systematically constructed and quite lovely, okay? And here's that here, yeah? So this is the slope field, y prime equals xy. Very lovely. And some things that I want you to observe about it, right? If you look along the x, so yeah, I should say, focus on that this is the slope field of y prime equals xy. And notice that when x is 0, which corresponds to the y-axis, notice how all of the line segments along the y-axis, are you looking? Notice how they are all horizontal. And that's because if x is 0, then x times y is also 0, meaning that y prime is 0. What does y prime 0 mean? It means that the slope of these lines, line segments, should all be 0, which means horizontal. Horizontal slope, 0 slope. Those are synonyms. And similarly, if you look along the x-axis, you can see that, again, the slopes of all of those little line segments that are all 0. All right? Down in the lower picture, in red, you can see integral curves to this slope field. Those represent particular solutions to the differential equation y prime equals xy. And you can see there are different particular solutions corresponding to different initial conditions. Indeed, remember the idea from a previous video that you can pass from the general solution to a particular solution by specifying an initial condition, okay? So this is the concept of a slope field. This gives you a picture of a differential equation, at least a first order differential equation. So cool, that's great. All right, see you in the next one.